CIT 1124, Module 12, Submodule 2, Wireless LAN Components. Let's take a quick look at wireless LAN components. It's going to start with some components that you guys are already familiar with. One of them being wireless network interface cards. What's the difference between a wireless network interface card and a wired network interface card? And the answer is the type of frame header that you're going to be sending and receiving. We know that wired Ethernet is one of the simplest frame headers that there is. There are 3 fields. There is a source and destination MAC address. That's 2. There is a type field, which identifies what the packet header is formatted as. That's it. So you need those 3 things. And in a wireless solution, you need more than those 3 things. You need to know what channel you're going to connect to. You're going to have an authentication and sometimes even an authorization to be allowed to join a wireless network. You have to identify the signal of the SSID value, or the name of the wireless network that you want to connect to. There is a signal strength component so that if you're moving around, you can seamlessly hand off between one antenna and another one. So there's all these other things that have to happen in wireless that don't have to happen in wired, because in wired, we're at a set frequency as we pass data, and the Ethernet cards are designed to tune into that frequency and listen for zeros and ones and then just identify what's what. So in a wireless solution, the frame headers and the overhead of communication is greater than it is with a wired, just an electrical signal that's going to be translated into a 0 or 1. So the wireless adapters are going to be necessary. In the next slide, it just talks about the basic home router device, which has really, it's 3 devices in one. It's a router. It'll get you out to the internet, right? It'll get you off your local network. It's a switch. If you have a couple devices plugged into it, it'll allow you to pass across that switch and have LAN communication. And it's an access point. And an access point is defined as just a device that's going to take the 802.11 Ethernet, 802.11 frame headers and convert them into Ethernet 2 frame headers. It's just going to take that information that you need, the MAC addresses and the type field, and it'll place them into an 802.11 header and put it on its way, put it on a modulated wave and send it on its way out into the air, or it'll accept something that it receives from the air, and it will remove all of the wireless specific headers and fields and leave you with just an Ethernet 2 frame header that you can use on a wired network. So the access point is just a frame header translator, I guess would be the easiest way to describe that. Access points again. This just shows a nice picture of these Cisco Meraki access points. You might hear about these. They're nice. They're fine. A lot of the access points that you're going to find these days are going to be used with wireless controllers and CapWAP, and we'll get into that in a second, and not in this particular video, in another one. Categories of access points. Okay, so 2 different types. There's autonomous APs, and then there's controller-based APs. These diagrams are actually pretty good. If you look at the top one there, the top picture, and you look at that as an autonomous access point, the access point's doing it all, right? It is an antenna, and it's translating the signal, and it all comes in and out of that. That's kind of like one you would buy from home, or maybe an access point that you would set up and plug in and program. It'll do everything. It's got a logic. They're going to be fairly expensive. When we look at the controller-based access points, the controller-based access points are going to have multiple antennas that are just going to pass information back to that particular controller. So this just says lightweight APs, LAPs used for lightweight access points to communicate with the wireless LAN controller. They could have many SSIDs. You can program one device, and it'll just pass it along to all the other devices. So you can provision everything all at once. Most of the organizations have now come to, even if you're using autonomous access points that have logic and built into them, they'll have a master control panel where you can basically have all the access points be added into a specific group, and you can program them all the same way. And it's a lot like controller-based, except for you've got all the logic on each one of them. You could program them individually, but a lot of times what you'll do is you'll program them uniquely and just pass the information over to the devices. So last slide in this section gets into just wireless antennas. There's a lot of different types of antennas that are out there. In most cases, the ones that you're finding in your devices are going to be called omnidirectional, and they just will pass wireless energy out in like an orb out of that access point, out of that antenna, so that you've got communication in any given direction. You can also focus. You could focus that energy with a directional antenna, and they've got a nice picture of one there where you would see like more of a focused. And then there's MIMO, which just means multiple in, multiple out. It means that you can have up to many devices connecting to, and you can start to utilize more than one antenna for your solution, and that will increase your speeds.